3, 2, 1.
Okay, so this is problem 29.7, where we're asked to find the electric potential energy of the group of charges here. A 2 nanocoulomb charge, we're calling charge 1, a 3 nanocoulomb charge, we're going to call it charge 2, and a 2 nanocoulomb charge, we're going to call it charge 3. Now we're going to use the equation to find the electric potential between each set of charges, and then add that together to find the total electric potential difference, or energy. So let's find this radius first, actually, because that's going to come into it. Using Pythagoreans, we're going to find that this is the square root of 4 squared plus 3 squared, which is 5 centimeters. And we're going to go right into our equation, which is U electric equals, which is potential energy, K times the charge of the first charge and times second charge all over the distance between the two charges. And K is equal to 1 over 4 pi epsilon naught. Epsilon naught is a constant that is actually 8.85 times 10 to the negative 12 coulombs squared per Newton meter squared. So, and that's going to be important because we're going to want to get joules here. So let's go into the potential energy between the first two charges, 1 and 2. So U of 1 and 2 equals K, which is 1 over 4 pi epsilon naught, multiplied by the charge of the first, which is 2 times 10 to the negative 9 coulombs, times charge of the second, which is 3 times 10 to the negative 9 coulombs, all over the distance between them, which is 0.04 meters. So when you look at these units, since this is on the bottom, that meters cancels out with the square there, and then this comes up to be a coulomb squared, which cancels with that, which leaves you with Newton meters, which is equal to joules, which is cool because that's what we want. When we crunch out this math, we get U1, 2 equaling, sure I get the right one. Okay. 1.35 times 10 to the negative 6 joules, Newton meters. So that's the first thing. And then the potential energy between 2 and 3 is equal to K, which is 1 over 4 pi epsilon naught, times charge of the second, which is 3 times 10 to the negative 9th coulombs, times charge of the third, which is 2 times 10 to the negative 9th coulombs, all over the distance between them, which is 0.03 meters. And that math works out to be 1.80 times 10 to the negative 6 joules. Second part. So the third part is between 3 and 1. So electric potential between 3 and 1 is equal to K, which is 1 over 4 pi epsilon naught, times charge of the third, which is 2 times 10 to the negative 9th coulombs, times charge of the first, which is 2 times 10 to the negative 9th coulombs. So 1. All over the distance between the two, which is 0.05 meters. That's a 5. And when you work with that math, electric potential between those two is equal to 0.719 times 10 to the negative 6 joules. So I'm going to go over here because there's free space. U total is equal to U from 1 to 2 plus U from 2 to 3 plus U from 3 to 1. So that's equal to 1.35 times 10 to the negative 6
Yeah.
joules
Plus.
1.8 times 10 to the negative 6 joules plus 0.719 times 10 to the negative 6 joules, which is equal to 3.87 times 10 to the negative 6 joules, which is the total potential energy of the system. Well, that was a lot of math, but it worked out for us. So yeah, that's all good.